Hi IoT guys, welcome back. For those of you who don't know me, my name is Johan Ahrens. I'm a Cisco systems engineer out of Montreal, Canada. Today we are going to discuss about a challenge I've received for one of my customers. They asked me to use a dry contact on the IR829. And for those of you who are less familiar what an IR829 is, this is an IoT gateway. This device has LTE connectivity, Wi-Fi. There was an access point embedded in this unit. It's a dual band, 2.4, 5 gigahertz. You have a few switch ports, and more importantly, you have two serial ports. But there was no dry contact. But by the way, what is a dry contact for you guys? A dry contact is just a simple way, a digital way to know if a circuit is open or closed. If you have a security system at home monitoring your doors and windows, you already have a bunch of dry contact at home already. So this is what the customer want to do with this dry contact. They want to monitor a push button or a turnkey, something like that. But there was no dry contact. And we do have some dry contacts on switches like the IE2K, 3Ks, 4Ks. They already have one. And then in iOS, you can actually monitor and program iOS to monitor if the contact is open or closed. But there was none on the IR829. What can we do with this? Well, we have two serial ports actually. It's quite interesting. But do you guys remember when we were in college, when the teacher was talking about legacy connectivity systems, serial ports and that kind of stuff, and he was talking about loopbacks. And what is a loopback, by the way? A loopback is just a way to interconnect a connector and to test the wiring of a system without installing another system. That's quite interesting. But what can we do with this? Let's go back to what is a serial port, by the way. I found actually a diagram of what a serial port is and the pinning description of each pin. Yeah, for the purist of the room, they would say, yeah, but this is a DB9. A real serial port is a DB25 with 25 pins, much more control pins. But for this setup, we only need 2 pins. There was the receive and the transmit. What if we will be young and crazy and send some piece of data and monitoring if we can receive that data? Will it work? Yeah, of course it's gonna work. How can we interconnect this? So we are going to use you see the red line over here. This is how we can interconnect the transmit and receive. And what if we will put a push button in between? So by default, the circuit will be open, so no data is going to pass through. But as soon as someone is pressing the button, the data is going to pass through and the circuit is closed. Then we can detect something. Will it work? Of course it will. So what do we need to do this on the IR829? Well, before doing so, I will suggest you guys to make it work on your computer. If you are lucky enough to have a serial port on your computer, fine, we're gonna reuse this. If you are just like me and you only have one laptop, the laptops no longer have a serial port nowadays. So I'm suggesting you guys to purchase this USB to serial dongle. So you can find this on Amazon or any computer store. This is very inexpensive. Secondly, you're gonna need to have some jumper cables, so female to female. If we zoom on the connector, so you're gonna see here we need some females jumpers, so we can actually plug in the connector, so it's going to be easier. And then you're gonna need a male connector, so you can actually interconnect this like this. So you can plug my male jumper into the female, just like this, and you can connect it. Oops. You can connect it just like this, and the circuit is closed. So this is an easy way to do it. If you are willing to spend a little bit more bucks on this, I will strongly suggest you guys to acquire a breadboard. And a breadboard, this is a more elegant way to do your test and trial with the circuit. And if you want to be a little bit more fancy, I would suggest you to acquire a push button. It's costing a few cents. So if we are zooming over here on the camera, so you see here the push button, and we have a few jumpers, male jumpers, so I can actually interconnect this with my my serial dongle, I can do this, and I can connect it over here. All right, and I can do this connection this way. Okay. So each time when I'm pressing the button is going to trigger the action. The next piece you're gonna need a script. And actually the script is already done, and if you want to have access to the script, you can click on this link. This is my GitHub, and this is where I'm publishing all the scripts I'm doing for my IoT project. So you go ahead and use the script. This is for you. So, but now I would like to drag your attention to a few lines of the script. The script is taking into as parameter what you are going to start the script. You're going to need to give a parameter to the script. So this is going to be the serial port name. So the script is just validating the parameter you gave is existing in the system, and then we are starting the process. So the first line that I would like you guys to focus on is this one. So we are going to instantiate the serial port. The device is just a variable in Python containing the parameter you gave to the script. Then this is the speed of the port, 9600 bits per second. This is plenty of speed for what we need to do. And then the timeout, this is 1 second. Then we are going to start the treatment. So we have an infinity loop, and yes, we can do it. We were yelled at when we were at college, but we try to do that, such things. But here this is okay because the script is going to pause every 10th of a second. Then the script is starting by sending 1 byte to the wire. Then we are reading right away the same serial port. So this is okay because there was a buffer, and as we are writing and reading at this, and we are writing and reading at the same time, that's okay. So we can do this. We are validating the received data. If the length of the data is 1 byte, if this is the exact same byte, this is okay. And why do we do this? Let's imagine we're going to install this system in a big machine, and maybe we're going to have a lot of electromagnetic interferences. So we want to make sure we didn't catch some interferences over the wire. So this is why we're doing this. Those two conditions are true. We are going to print button pressed. If it's not, we are going to print the message button not pressed. Okay, sounds good. So next we're gonna give a try to the script. My connectivity is done, my breadboard is connected, I have my press button, everything is connected, and here is my script. I'm going to fire up the script, python button.py, so this is just the script name, and then /dev/tty USB 0. This is just the name of the serial port on Linux. So let's do this. So you see the script has instantiated the serial port, so you see button not pressed, and if I'm pressing the button, you're gonna see button pressed. Does it work? Yeah, it works. Perfect. So I'm going to stop the script. So next we need to make this work on the IR829. That's another challenge. And why is that? Well, let's have a look on the router itself. We have no DB9 on that equipment. That's the problem. If we are zooming over here, you see this is RJ45. Well, the pinning is certainly different on that equipment. I've done the job for you to make it easier for you. So in the installation guide of the IR829, there is the table 6 containing all the pinning of those RJ45 connectors for the serial port. And there are actually 2 pins that are interesting us, the receive and the transmit. This is the pin 5 and 6. But as this is RJ45, the connector is different. How are we going to connect this? What I'm suggesting you to do, grab any patch cord, take the oldest one that you have, just cut it in through and just skin it. And which wire are interesting us? If we look at the theory, how we actually terminate patch cord, there are 2 ways to do it. There was T568A and 568B. Most likely is going to be B because patch cords are usually terminated in B, but just in case and just for a sanity check, just validate it. So the way to do it, take the connector in front of you just like this, and the pin facing down, and look at the colors of the wires. So mine is B, and in B this is the blue white and the solid green. See the pin 5 and the pin 6. I've skinned a patch cord already. So here is my blue white, and there is my green, solid green over here. So we are going to interconnect those guys in the breadboard. Okay, so we're going to disconnect this guy, and then we're gonna connect this to the green. This is going to be connected to the green, and this one, this is the blue, is going to be connected to the blue white. So yes, I've used some female jumpers to make it easier. So this is done. And now how can we make it work? What I've done already, due to time constraint, I've already packaged the application for IOX. The next video I'm going to shoot is to demonstrate how you can take any script and make it work in a container in IOX. And this is something I've already done, and I've distributed my app using Kinetic GMM. And for those of you who are less familiar what Kinetic GMM is standing for Gateway Management Module. And this is a cloud offering Cisco has to allow you to manage your gateway from day zero. And if you are interested to know more about Kinetic GMM, I've recorded another video about the subject and need to bring you to that video. So moving forward, let's have a look on how the script is running. So here I'm clicking on gateways, and this gateway that is up, this is my lab gateway, so I can click on it. I can click on apps over here, and here button -test.1.4, this is my app. I can click on it, and you're gonna see here application logs. And the way I've done this, so remember when the script was executing, it was just printing button not pressed or button pressed, depending. And what I've done, I've just redirected the output of the script into a file, as simple as that. Keep it simple, this is my mojo. And here everything is logged in the log button.log, all right? If I'm clicking the plus button, we're going to see here it's grabbing the content of the file, and you can see here button not pressed. All right, sounds good. All right, I'm going to scroll up. I'm going to close the file, and I'm going to press the button, pressing a couple of times in a row. And actually, let's grab a new version of the file. All right, and let's scroll down, and there it is. Button press, the script is working. Just to summarize what we have done today, we have discussed about using a serial port and to turn a simple serial port into a dry contact, and how simple it is to reuse whatever we have actually. And this is all about IoT, is to reuse whatever we have and to interact with the physical world. We have seen how we can actually use a press button to make it work, and we have seen how we can actually use a Python script to package this Python script and to distribute this script into an IoT gateway just like this one, to reuse the hardware we have here, and how to distribute that application, and then we can actually grab the data. Here, this is a simple action. This is only printing a button press or button not press, but this is up to you to decide whatever the script needs to do. The script could interact with any APIs of GMM or WebEx Team or whatever you see fit. And the sky is just the limit in this. All right, hope you find this video interesting. If you did so, please go ahead and like the video. If you haven't done this, please subscribe to the channel. And if you have any questions, or if you have any concerns, or you want to know more about the various sections or various pieces we have covered in that video, don't hesitate to comment. I'm going to review the comments and to reply to you guys. So thanks for watching, and see you in the next video for the packaging of the application.